Do you have that one friend who's always asleep? Do they miss your calls in the middle of the day because they fell asleep? And even when you do hang out with them, they fall asleep? Sometimes it even happens when you're doing work with them.
Okay, let's work on embedded.
Sleep deprivation seems to be an epidemic among ECE majors at Cornell. How can we put a stop to this?
Guys, is the snooze feature working?
It feels cruel to shake or startle your friend awake when they're in the middle of a really good nap. Is there a more humane alternative? Perhaps with the use of embedded systems?
3, 2, 1, go.
Now presenting the Anti-Sleep Glasses by Mandy Chen, Amanda Huang, and Sarah Zong. As you can see from the demo, the design is very human. There's even a snooze feature that allows the wearer a couple seconds of silence to close their eyes.
Snooze.
Here's the snooze function in action.
For our hardware, we use an infrared reflective sensor consisting of an IR LED and a phototransistor to detect eye movement. The sensor detects reflected light from the white surface of the eye when the eyes are open, producing a digital low output. In this case, the LED on the sensor lights up and the buzzer rings. When no reflection is detected, meaning the eyes are closed, the output remains high. As you can see, when the sensor is facing this wooden surface, the LED on the sensor does not light up and the buzzer is silent. However, if I move the sensor to this white surface, the LED on the sensor lights up and we hear the buzzer go off. For our software, we created 5 new files: input.c, input.h, output.c, output.h, and main.c. Input.c manages peripheral devices including the IR reflective sensor and the snooze button switch. As you can see, we have an IR init function, a snooze init function, and a read IR sensor function that initializes all the ports and pins. In the input.c file, we also have a function called portc, port the IRQ handler, that implements an interrupt for the snooze button. With this file, we essentially just initialize the sensor and the interrupt for the snooze feature. We also have a corresponding header file that contains the function headers. In output.c, we control the buzzer connected to PTE31 with functions to turn the buzzer on and off. We also have a corresponding output.h file with all the function declarations from output.c. Finally, in main.c, we initialize the hardware components, read the sensor output, and activate the buzzer when the eyes are closed for a long duration. This file essentially determines if the eyes are closed and triggers the appropriate response. If the sensor reads 1, then there is no obstacle, meaning the eyes are open and the buzzer does not ring. Otherwise, there is an obstacle detected, which means the eyes are closed and the buzzer is triggered. In terms of debugging, we use standard debugging strategies such as compiling/building the project and using the Flash tool to assess code behavior. Most bugs were minor syntax errors, but one significant issue was using a faulty pin for the snooze button, which we resolved by switching to a different pin. Specifically, switch 1 on the FRDM board, so this left button here, was not working properly, so we had to switch to using switch 3 instead, which is this right button. Either way, both switches were connected to port C, and switching to switch 3 allowed us to implement the snooze button.